All right, today we're going to talk about developing formulas for circles and regular polygons, section 9.2. We've already talked about circles earlier in the year. We talked about circles back in chapter 1. We're going to continue to talk about them a little bit. The hard part today is going to be the regular polygons. So developing formulas for circles and regular polygons, section 9.2. Circumference and area of circles. Both these formulas should look familiar. We did it earlier in the year. They are up all around the room. If you look across the posters, there's some formulas up there. Circumference and area of circles. A circle with diameter d and radius r has circumference c equals pi times diameter, or c equals 2 times pi times the radius. Now again, why is it twice the radius? Because if you double the radius, you get the diameter. So same thing. And then a circle with radius r has the area a equals pi r squared. Okay, so the area is the radius squared. Circumference is double the radius, and then they're both still times pi. Now those are cut and dry formulas. We're going to have problems like this today, though. Find the circumference of circle S in which the area is 81 pi centimeters squared. Well, to do a problem like this, you have to work backwards. So for instance, start with the formula, plug in the information you know. For instance, I know the area is 81 pi. I want to find the radius. Well, what's the opposite of a squared term? It is a square root. So the opposite of a squared term there, again, is I square root it. So square root of 81 gets me 9. So the radius has to be 9. And then I go answer the question. The question says find the circumference. So I take that radius, plug it into my circumference formula, and I get the circumference is 18 pi. Okay. Again, just kind of using all the formulas you know about this and working out the missing information. Let's try number 1. Find each measurement, the circumference of circle B. So I want to find the circumference of circle B. What is the formula for circumference, Caitlin? Or I'm going to do 2 times radius times pi. Is that all right? Sure. All right. So number 1 here. Which one do you want to use on this one, Caitlin? The diameter or the radius formula? The diameter, because I have the diameter. Yep. So c equals pi times 6 over pi. Why is it 6 over pi? Well, because that was my diameter. Now I want to simplify. What happens to my pi's here? They cancel, and I'm left with circumference is what? 6 centimeters. Yeah, kind of a unique problem. There's no pi in my answer there because, well, the pi is canceled out. Number 2. Find the area of a circle R in terms of pi. What's the formula for area of a circle, Tyler? Look on the previous slide. Huh? Why don't you look up on the board up there to your left? Nope, to your left in the black, bottom left corner. Yep, that's circumference. I want the area. Pi times radius squared. So the area of circle R in terms of pi. I'm given the radius here. What's the radius, Tom? On number 2, what's the radius here? It gives me 5. So pi times 5 squared. So I'm going to write this as an answer in terms of pi. So what is 5 squared? So my answer is 25 pi meters squared. Now why is it meters squared? Because we're talking about area. Whenever we're talking about area, it's always going to be units squared. Yep. If it says in terms of pi, just leave it like that. If it wants you to actually find answers to a decimal, then you actually calculate pi. And what's the best approximation for pi? 3.14. Number 3. I swear she said 2 too. I thought I heard 2, but it is 3.14. Number 3. The area of circle Z in terms of pi. Now to find the area, I need to use the what? The Do I need to use radius or diameter to find area? Radius. What does it give me in number 3? It gives me the... How do you find the radius then? Yeah, if I divide that by 2, I get 11. So area equals pi times 11 squared. So what's 11 squared, Ryan? So my area is 121 pi feet squared. Nice job. And number 4. Number 4. The circumference of circle T in terms of pi. The circumference of circle T in terms of pi. Circumference, I need the what? I can use radius or diameter, doesn't matter. Which formula would you like to use here, Troy? Okay, so what's the diameter in this circle then? My diameter is 20. So I do C equals pi times 20. Which then my answer is what in terms of pi? 20 pi what? Inches. Circumference is not squared. It's just area that is unit squared. Nice job. Again, that's using the formulas for circumference and area. Using that information, take a couple seconds and try numbers 5 and 6. Number 5, it says the circumference of circle X in which A equals 49 pi inches squared. Well, it gives me the area. So what can I find right away? I can find the radius. What's my radius equal then, Noah? 7. And if my radius is 7, what's my circumference then? 14 what? 14 pi. Nice job. And number 6. The radius of circle Y in which the circumference is 18 pi. Well, if the circumference is 18 pi, what's my radius have to be, Tina?
9 meters.
How did you find that? Yep, 18 divided by 2, and you get 9, because we're having circumference. Good work. All right, so circles are the easy part. Good, because regular polygons are the tough part. All right, we're going to talk about the area of regular polygons. The area of a regular polygon with apothem A and perimeter P. Now, listen, please, because you will need to know this. The formula is area equals half the apothem times the perimeter. Okay. The apothem, now, might want to make sure you jot this down. The apothem is the distance from the center to a side. So if you look here, that is the apothem. What is the apothem very similar to in a circle? Radius. The apothem is very similar to like the radius. Okay? Very similar to like the radius here. And again, the center is equidistant from the vertices. Yes, sir?
So, like, could that ever be different?
Alright, so the apothem is the distance from the center to the side. And we have to use what we know here to find apothem. Now, P stands for perimeter. Perimeter is just the distance around, recall. So that's kind of straightforward. Nothing too hard there. Let's look at the first problem here. Now again, you will have to show some work on these. You will have to do a lot of work. For example, find the area of a regular hexagon with a side length of 10 centimeters. Now notice, if my side length is 10, that means all of these side lengths are what? 10. Okay, important to know. Now, step 1 says, draw a figure and find the measure of a central angle. Central angle means like the angle from the center. Each central angle measure of a regular n-gon is 360 divided by n. Where does that 360 come from? Does anybody guess? Circle. If I were to go all the way around on the inside there, I get a circle. Circle is 360. So to find the central angle, I take 360 divided by the number of sides. So how many sides was this one? It's a hexagon. That means it is. So I take 360 divided by 6, and I get 60. Now notice, that is not how I get my apothem. My apothem comes from that central angle, though, on a direct line down. Ooh. If you look over here, it kind of shows it better. How do they get that angle of 30 degrees, do you suppose?
Because they chopped 60 in half.
You cut it in half. Oh, wrong button there. Yeah, you cut that one in half. So you take 60, cut it in half, and I get an angle that is 30 degrees. Now, here comes the tough part. Step 2. You want to find the apothem. I have this angle is 30 degrees, and I know this one is 5. How do you find the apothem? I have to use what functions?
30, 60, 90.
Tangent functions. I'm going to have to use tangent functions to find those missing sides. That is important. That's the toughest part about today, is you're going to have to use tangent functions to find some missing parts. So notice they did tangent is our TOA part. So tangent equals the opposite over adjacent. So tangent of 30 equals 5 over A, which is the same thing as 5 over the tangent of 30. So that means that is my apothem. And then what they do, they plugged that information into the formula. So half of 5 divided by the tangent of 30 times 60. Now, you could simplify this. Do you have to do half of 5 divided by tangent of 30? Or what would it be easier to do half of? Half of what? 60. Yeah, it'd be a lot easier to do half of 60 here, wouldn't it? So break this down as 5 over the tangent of 30 times 30. That would probably make this a lot easier problem, a little bit less work. All right, but that tangent is where a lot of students struggle on. Okay.
So you always use tangent?
Yeah, pretty much. Number 7 here. I want to find the area of each regular polygon round to the nearest tenth. So I'm looking at number 7 here. How many sides does number 7 have? 8. There are 8 sides. Awesome. So to find my central angle here, how would I find my central angle? I take 360 divided by 8. What's 360 divided by 8? 45. Now I need to find the apothem though. The apothem is the straight line there. Well, how do I find the angle then on either side of the apothem? I take 45 and divide it by 2. So this angle right there comes out to be what? 22.5 degrees. Awesome. Now, I know this whole length down at the bottom is 12. Does everybody agree that whole length right there is 12? So what's half of that length going to be? 6. Now, can I use trig functions to find my apothem? Yes, I can. I would do the tangent of 22.5 equals the opposite side is 6 over the adjacent side of x. So tangent of 22.5 equals 6 over x. Now when we're doing these, you can round everything to the nearest tenth. It does say round everything to the nearest tenth, just so you will be using a calculator and get decimals. What's that then? Tangent 22.5 equals 6x. What's x have to be here? 14.6 then? Let's go to about 14.6. So my apothem, A, equals 14.6. Awesome. Now I'm going to use my formula for the area of a regular polygon, which is A equals 1/2 A times the perimeter. So A equals 1/2. My apothem was 14.6 times, how many sides do I have in this shape? I have 8 sides. What is each side length? 12. So just 8 times 12 is the perimeter. Does everybody understand how we get that? There's 8 sides. Each side's 12. I could multiply them. I could just write it out. So half of 14.6 times 8 times 12 gets me the area to the nearest tenth. My area is going to be approximately what, Max? 695.7 centimeters what? Centimeters squared. Whew. That's a good problem right there. And what's the toughest part? Finding that apothem using the tangent function. I think he used the actual decimals, didn't you? Did you not round? I don't think he rounded. So I think he used the actual whole decimals. If you rounded, what'd you get? 700.8. 700.8? So those are both pretty close then. Nice job. Number 8. Let's try number 8 here. Notice, what am I given in number 8? I am given the apothem. I need to find the lengths down at the bottom. Okay. Well, I'm just going to draw a right triangle right here. Great. How can I find that angle on the inside? 360 divided by what? 360 divided by 5 gets me. And then I divide that by 2 and I get. So that angle right there is 36. Because I cut in half. Because I'm finding 72 is this angle, but I want half of that. Now, what tangent function can I use to find this little small part right there? I'll call that x. How would I set that up using tangent? Tangent of 36 equals, what's opposite of 36? X over the adjacent side is 4. So tangent of 36 equals x over 4. Nice job. Yes, sir? Yeah, typically. Okay, now I need to find x here. What does x equal? Mr. Nault. What is it? About 2.5? Is that everybody got? 2.9. I think it's about 2.9, isn't it? So about 2.9. Awesome. So that's that small side, 2.9. But remember, I need to find the whole length here. What's the whole length? How would I find the whole side there then? Double it. So the whole side is what then? 5.8. Awesome. Now I can use my formula here and find the area. So area equals 1/2 times the apothem of 4 times how many side lengths do I have here? Times my side length of 5.8. So 1/2 times 4 times 5 times 5.8 gets me the area of this pentagon is what then? 58 what? 58 inches squared. Nice job. Again, it is a little bit tougher on the regular polygons just because of the apothem. Let's try number 9. What's wrong with number 9? They don't give us a what? Diagram. You don't want to find a diagram here. Hexagon has how many sides? 6. Hexagon has 6 sides. So I have 1, 2, 3, 4, 5, and 6. Okay. It says the apothem is what here? The apothem is 3. How can I find the angle now? How would I find the angle? 360 divided by 6 equals 60. And then I want to take 60 and divide it by 2. And I get that angle is 30 degrees. Nice job. Now I have to use trig functions to find the smaller base down there. How would I set that up using trig functions, Caitlin? Tan of 30 equals x over 3. Nice job. So what does x come out to be then to the nearest decimal, 1/10? The bottom part comes out to be what there? What did you say? 1.7. Awesome. Now that's just the part down there though. How do I find the whole side then? I have to double it. So the whole side down at the bottom would give me what then? 3.4. Now do I have enough information I can plug it into my formula? You bet. So I would do half, what's my apothem? Times my, how many sides are in this?
6.
Times 3.4. So 1/2 times 3 times 6 times 3.4 gets me my area comes out to be to the nearest 10th. My area is approximately what, Mr. Nault? 30.6. meters squared. Nice job. I know, a lot of work on regular polygons. A lot of work. Okay. Number 10. A regular decagon. How many sides is a decagon? 10 sides. Nice job. Now, it has a perimeter of 70. Now, I'm really bad at drawing decagons, so I'm just going to draw kind of this partial triangle here. Okay? Because I'm really bad at decagons. If the perimeter is 70, what's the length of each of those sides going to be then? 7. Each length is going to be 7. Now, if each length is 7, what is my central angle going to be here? How would I find my central angle? 360 divided by what? 10, which is, and then divide that by 2, and I get 18. So that means that angle right there is 18 degrees. Now, if my bottom is 7, what is my partial side at the bottom going to be? 3.5. Awesome. Now, trig functions, what can I use to find A there? My apothem. Using trig functions, what can I do to find A? Somebody give me the tangent function. Set up correctly. Tangent of 18 equals 3.5 over x. Nice job. So tangent of 18 equals 3.5 over x. And you're going to solve for x to the nearest tenth. Solve for x to the nearest tenth. What'd you say? 11.7. So my area is going to equal 1/2 times 11.7 times, what's my perimeter? 70. You gave me the perimeter in the problem, right? It's 1/2 times 11.7 times 70, and then to the nearest tenth. What'd you get? About 409.5. Is that what you got? Is that what you got? Work it out. Somebody else checking. 409.5? Awesome. So that is about 409.5 feet squared. Nice job. You gotta recognize there's a lot of work that goes in these. Okay, you have to make sure you show your work and go through it here. Try number 11. Take a couple seconds and try number 11. Don't worry about number 12. Try number 11. Great. All right, number 11 here. So if you looked at this, the central angle was 30 degrees. And because the central angle is 30, to find the bottom part, you'd have to use tangent. So tangent of 30 equals x over 18. And you would have had to multiply 18 times tangent of 30. I think you end up with, was it 10.4? Is that right? Which means the whole side at the bottom then is 20.8. So then I would do my area equals 1/2 times 18 times 6 times 20.8. And you come out to be, I think the best answer I've seen was about 1,122.4 inches squared. Nice job. Now number 12 was a little bit tougher. Why is 12 tougher? Because you don't have a side length or the apothem. So you had to find both of them. Now in order to find both of them, you have to actually use trig functions using sine, cosine. And I think the side there, what's he get for the one side, Troy? Using sine or cosine? I think you're going to take 6 times the cosine of, what's my interior angle there, 36? What'd you say? 4.9 or 4.8? And then what's the opposite side then, Troy? No, I didn't say not on 12. Yeah. T-Roy, what'd you get, man? What's the answer? 105.5 meters squared. And you have to use sine and cosine of those functions there. That's why that one's a little bit tougher. But don't worry about that one. That's the tough one.
Do we have any like that on our assignment?
Here's your assignment.